Hello everyone, my name is Doug Schwartz. I'll be your instructor this semester and welcome to College Algebra, which is Math 1220. So when you check out this video, and this is for the future too, anytime you watch a YouTube video that I do, make sure you pick Math 1220. They're all labeled because we also have other courses that we YouTube, my brother and me. So always do 1220. Okay, so let's get started with the equations. That's going to be topic number one. And here we go. I tried using a tripod, but I was unsuccessful with that, but I'll try it again later. But for now, I'm just going to hold the phone with one hand and try this. All right, so let's try this example here. Solve for A. And we got this equation. B equals the quantity x minus a times k. So that's a multiplication there. This whole quantity times k. We want to solve for that a right there. So we want to get that all by itself. And it seems like a tall order. This k is in the way. So let's get rid of that k by dividing both sides by k. So I know you do the opposite of what the variable's doing to the variable you want to solve for. So let's divide both sides by k. So when we do that, we get this. And that's called the division principle of equality. You can do whatever you want to both sides of the equal sign and be left with an equivalent equation. So dividing both sides by k, we get this. Notice I don't need to parentheses any longer because this quantity is not multiplying with anything on this second step. Okay, next, I want to get a by itself. How about subtract x from both sides? You can almost look at this as x plus a negative a. So do the opposite. Okay, so when we subtract x from both sides, b over k minus x equals negative a. Don't ignore that minus sign there, and it's, or you can think of it as x plus a negative a. So all I did was subtract x from both sides, so that's got to be a negative a on the right-hand side. I want to solve for positive a, not negative a. So let's multiply both sides by negative 1. Oh, I could do this. I'm going to show all my steps here. Negative 1 b over k minus x equals negative 1 times negative a. The multiplication principle of equality, that is. I'm multiplying both sides of the equal sign by the same number, negative 1. Okay, let's use a distributive property on the left-hand side. What's negative 1 times b over k? That's going to be negative b over k. And then what's a negative 1 times a negative x? A positive x equals positive a. So there's our answer. Just for fun, I could have done an interesting idea right here. Let's see, I'll draw this double arrow. It's a cool symbol in math. It means continuing to thought. So from this step, I could have done something clever here. When I multiply this left-hand side by negative 1, whenever you're subtracting two terms like we are here, if you switch the order, it's the equivalent of multiplying it by negative 1. For example, how about 7 minus 3? We all know that equals 4. What happens if I switch the order of these terms and I go like this, 3 minus 7? Doesn't that equal that 4 times a negative 1 or negative 4? So along those lines, from here, I could do this. Switch those terms around. X minus b over k equals a. So in a sense, I multiplied both sides by negative 1 to get that. So notice, these are the same. This one and that one. The two circled ones are the same. In this case, look at this term. Look at the second term here. Isn't that a negative? That term, b over k, is negative, and isn't it negative here? Yep. And isn't x positive here? And isn't it positive here? So indeed, they're the same answer. Okay, so we solved for a there. Let's try another problem. Before we do that, though, let's go back to the first step. Some people might have done it this way. How about b equals, use a distributive property on the right-hand side, so you get xk minus ak. And then we want to solve for a. So how about subtract this term from both sides? This way is a little bit longer. I like the way I did it the first way better. Let us subtract xk from both sides. So let me erase this b here. All right, so I get b minus xk equals negative ak. Okay, and now let's divide both sides by k. Or let's by negative k. Let's do that. Let's divide both sides by negative k, because I want to solve for a, positive a. So let's divide both sides by negative k, and we'll get this. B minus xk over negative k equals a. Wow. So that's the same answer. It's definitely a little awkward looking. I could clean it up a little bit better and call that. I'm allowed to switch. I want to solve for a. It's okay if I switch this a to the right, to the left-hand side, and this to the right-hand side. You're allowed to flip it over an equal sign, same thing. So I could rewrite it as a equals b minus xk over negative k. Okay, that's, let's see. Or isn't that the same thing as, let's multiply top and bottom by negative 1. That won't change the value of this fraction. Because if I multiply both sides by, I multiply both sides by negative 1 over negative 1, isn't it the same thing as a positive 1? Negative 1 divided by negative 1 is positive 1. So let's multiply numerator straight across and denominator straight across. The reason I want to do that, it looks a little bit better because we don't like to see negative signs in the denominator. So let's try that. And if I multiply this by negative 1, let's do that trick. Whenever you're subtracting two terms, switch the order, and it's like multiplying by negative 1. So I'll go xk minus b over k, and let's see, does that look like anything? Let's see, xk minus b over k. Let's see, that's the same as this one right here. They just look a little different. Let's see, well, let me just look at this for a second. B over k, b over k. Yeah, convince yourself that's the same thing. And it does indeed appear to be the same thing. Let's move on now to the next problem. But, let me I could divide every term by k. So I get, let me just do this cool symbol, and I get, let me just rewrite this. A equals, what's x over k divided by k? Isn't that just x? And then minus b over k? And isn't that the same thing as over here? Sure. So indeed, these are the same thing. Okay, let's try another problem here. I'm really starting off with some doozies here. That was a pretty tough problem. I should have started off with something easy, like how about x plus 2 equals 9? Subtraction principle of equality, and subtract 2 from both sides, and we get x equals 7. And that's easy enough to see by inspection or check here. If x is 7, isn't 7 plus 2 9? That was a lot easier than the last problem I did. Anyway, let's try another problem here. How about, let's say, solve for a again. Solve for a. And let's say we have this. A equals 1/2 times a plus b times h. Okay, so we want to solve for a. Right there we want to solve for. I see a fraction here that makes us all uncomfortable. How about let's use the multiplication principle of equality and multiply both sides of the equal sign by, in general, you do it by the least common denominator of all the terms. And it looks like that's just going to be, like, this is a over 1. And so it looks like 2 is the least common denominator. So let's multiply both sides by that least common denominator 2, and good things will happen. All the fractions will disappear. So multiplying both sides by 2, we get this. 2 times a equals, this is a product here. What's this times that times that? If I multiply this by 2, this whole right-hand side by 2, there's no distributive property here. Just, what's 2 times 1/2? Isn't that just 1? And then what's 1 times a plus b? A plus b, what's a plus b times h? A plus b times h. So I'm going to write this. Okay, we want to solve for this a, not that capital A, the small a we want to solve for. How about divide both sides by h next? Because we want to isolate that a. So we have that. And looks like now what we want to do is subtract b from both sides. 2a over h minus b equals a. That was the subtraction principle of equality. Again, when you have an equal sign, you can do whatever you want to both sides of the equal sign and be left with an equivalent equation, as long as it's the same thing. So that looks good for that problem. Let's try another one since we're on a roll here. And if you're not careful with these, you might have fun with them. Let's try, how about solve for u? Usually it seems like it's solve for x. I'm coming up with weird variables here. How about 7u minus 6/5 equals negative 2/5 u times u. Notice when I put the variable u, I don't want to put it down low. I want to put it right in the middle of the fraction. Or it's okay if you put it in the numerator, but not in the denominator. So that looks good like that. I like it better midway in the fraction. Minus 4/3. So there's the problem. We want to solve it for u. So let's, for a first step, whenever you have variables on both sides of the equal sign that you want to solve for, get them on one side. So let's bring the variable terms together. What is 7u? I'm going to add 2/5 u to both sides. So I'll just show all my work here. 7u plus 2/5 u equals negative 4/3 plus 6/5. So I kind of did two steps at once here. I brought the u term over there and I put the number on the right hand side. So I'm adding 6/5 to both sides. That's where that comes from. Okay, and then next. Well, we got fractions. 7u plus 2/5 u. I mean, that's 7 and 2/5 u. But I'm going to multiply. Whenever I have fractions with an equal sign, why not multiply both sides, but a least common denominator to clear away the fractions? And what's the least common denominator of 5 and 7 and 5? 35. So let's multiply every term by 35. So so when I multiply the whole left-hand side by 35, it's a distributive property. Every term gets multiplied by 35. What's 35 times 7? I believe that is 105. So I'm going to write 105u plus 6u. Because again, what's 2/5 times 35? What's 2/5 times 35? I'll just show my side work here. Notice you can cross cancel when you multiply fractions. 5 goes into 5 once, 5 goes into 35 7 times. 7 times 2 is 14 over 1, which I don't need. So that's why I'm going to... let's see, where am I here? So what's 2/5 times 35 is 14. Let's see. Oh, I'm sorry, this was a 3 here. Oh, boy. Let's just erase this now, sorry. I couldn't read my own handwriting. What's the least common denominator now? 5, 3, and 5 are the denominators. 15 is the least common denominator. So let's multiply everything by 15, both sides by 15. That will clear away the fractions. What's 15 times 7? Yeah, that's 105. 105u. What's 2/5 times 15? 2/5 times 15. I can cross cancel. 5 goes into 5 once. 5 goes into 15 3 times. 2 times 3 is 6. So I'm going to write, so that term times 15 becomes 6u equals, what's negative 4/3 times 15? That is going to be negative 4/3 times 15. I can cross cancel here. Equals negative 20. So I'm going to write negative 20 plus, what's 6/5 times 15? That's 18. Okay, let's do the next step. Let's simplify the left-hand side. What's 105u plus 6u? Those are like terms because it's the same variable and the same exponent on that variable, an implied 1 and an implied 1. So add up the coefficients. 105 plus 6 is 111. U equals negative 2. Those are like terms. What's negative 20 plus 18? Negative 2. We want to solve for u, so divide both sides by 111. So we get u equals negative 2 over 111. Final answer. Wow, that was brutal. No, not too bad. Do we have time for one more problem? Yeah, let's do one more problem and then we'll call it a day. I want to make these videos short so we all can like them short and sweets. Okay, how about we have something like this. 4 over x plus 5 equals 6. Well, there's a few ways we can do this. We want to solve for x. That's the name of the game here. Solve for the variable x here. For what value of x will make this a true statement? If I go like this, here's an interesting way of solving this. And what is it called when you have one fraction equal to another fraction? I made that 6 over 1, same thing. A proportion. And the nice thing about proportions is their cross products are always going to be equal. Let me give you an example of that. How about 1/5? Doesn't that equal 3/15? If I reduce 3/15, don't I get 1/5? Sure. And notice their cross products. What's 15 times 1? 15? What's 5 times 3? 15. Notice their cross products are the same. That will always happen. So let's take advantage of that fact here and set the cross products equal to each other. So we'll be aggressive and set the cross products equal to each other. What's 6 times the quantity x plus 5? I'm going to just show all my work here. 6 times x plus 5 equals, what's 4 times 1? That's the other cross product. It doesn't matter which cross product you do first. So, again, a proportion, so that means their cross products are going to be the same. So I just went this way first because I guess I want the variable on the left-hand side. So what's 6 times x plus 5 equals the other cross product? 4 times 1 is 4. What do I want to do next here? How about divide both sides by 6? So, and then I get x plus 5 equals 4/6. I can reduce that right-hand side. How about x plus 5 equals 2/3? 4/6 reduces to 2/3. Just divide top and bottom by 2. Okay, then what does x equal here? Subtract 5 from both sides. X equals 2/3 minus 5. What is that going to be? X equals, I could get a common denominator here. I could almost do it in my head. What's a negative 5 plus a 2/3? Negative 4 1/3? Yeah, that looks good to me. Which is the same thing as if I want to write it as an improper fraction. Because right now this is a mixed numeral. As an improper fraction, you do this. How do you change a mixed number into an improper fraction? Take the denominator there. 3 times the outside term, negative 4, outside number. 3 times negative 4, and then you add that numerator, and then put it all over that. So 3 times negative 4 is negative 12, plus 1 is negative 11 over 3. So negative 11/3. Just to make sure that's right. 3 times what gives you negative 11? Ooh, that isn't right. What's negative 12 plus 1 is negative 12 plus 1 is negative 11 over 3. 12. Okay, I know what I did wrong. See, 3 times 4 is 12 plus 1 is 13. So let me make this negative 13 over 3. Wow, that was interesting. Okay, and then notice that is the same thing as negative 4 in the third, because 3 goes into negative 13 negative 4 times with 1 left over. So yeah. Okay. I could have done this by another way, multiply both sides, but at least common denominator x plus 5, but I like this way better. Okay, so that is good enough for today, and so try to keep up with this class. Check out Alex. They've got great videos, by the way, of these lectures as well. So don't be afraid to check that out. All right, good night, everybody.